He kind of you do? Tahira?
And so does Timon and Pumbaa. They all like Cairo.
Tyra likes Jada.
Jada?
Me. Oh, man, you point the headset, you chunky shit.
Okay, so just like earlier this week, we're still going to be working with equations. So what do you expect to see?
Equal something.
Yeah. And we're going to be doing the same thing with equations, which was to solve. Equations get solved. Okay. And what's another word for solving? When you are solving, what are you really doing?
Completing or doing. Oh, here. Simple sign.
It's a word, and I stress it. I said it over and over and over again.
Solving.
When you're solving, what are you doing? It starts with I and ends with solate.
Isolating.
Yeah, you're isolating, sure. So that's even more important to understand when we deal with the types of equations we're dealing with today, because these are called literal equations. Sometimes they're also referred to as formulas. They're equations that have more than one variable. And because they have different types of variables, a lot of the operations that you're going to try to do, you won't be able to do. You're not going to be able to actually add or subtract or multiply, divide. So the only thing you need to concentrate on is how you isolate them. Because there's going to be more than one variable, they have to tell you which variable to solve for. So like this equation has x's and y's. Here they're telling you to solve for y, so that tells you that you need to isolate the y. In order for y to be by itself, what would I need to cancel? Okay, just the 2, the 4, and the x. If I somehow had like a magic math eraser, I could erase the 2, the 4, and the x, and y would be by itself. But I don't have a magic math eraser. They were sold out when I went to go buy one. So I'm gonna have to use operations. Okay, so let's talk about when. Meaning, like, when am I going to get rid of each one? Which one would I get rid of first? Lord? The 4 and the x. That's an entirely separate term. How would you get rid of it? You would subtract it. If you subtract on the left, you subtract on the right. But this is when the children start to get confused. Because the word, yes. Yeah, don't say it because you might say something and then get embarrassed, and we don't want to make these silly mistakes. So, one of the silly mistakes is that which I really hope we're not making, Jair, is when people say, "Oh yeah, that's 4x." Ooh, no. So what I would hope is at the very least you recognize, hey, these are not like terms, but instead of having your brain explode trying to figure out how to subtract them, just realize when they're not like, it just stays as is. Subtract 5. Where are you getting a 5 from? I would hope if you're saying 8 minus 4, you know that it's 4, but then I would also hope that.
I'm just saying because like the 4x.
These cannot be combined. Now, the other thing you could do, and this is more getting ready for when we get into graphing, because when you get into graphing, you're going to see x's and y's, is you get used to writing the x in front. Just make sure that the x is negative, and then the 8 is positive if you were to write it in front. Negative 4x, positive 8. You could either write that or 8 minus 4x. What's the last step to get y by itself? You have to division it? Yeah, what am I going to divide by? In most of these, okay, on most of these problems, you'll be done already. We wanted to isolate, and the y has been isolated. And all you would do is just write down whatever you had on the other side. Because very seldom can you actually do these operations. But this is one of the few times that you can. Because both of the numbers on the top are divisible by 2, I've heard this called the pretzel. You would divide each one by 2. What is negative 4x divided by 2?
Negative 2x.
Negative 2x. What is 8 divided by 2? Positive 12. And now we're done. That's not going to end up on my floor, right, Orlando? So I can add that to the referral if you need me to. Here to serve. Solve for y again. In order for this y to be by itself, what do I have to cancel out? The 3n? No, I don't want to. If I cancel the y, it wouldn't be by itself. So the 3 and the negative 7. If I can get rid of the 3 and the negative 7, the y would be by itself. So that's the what. Now let's go with the when. Which one am I going to get rid of first? Now the negative 4. The negative 7. I'm going to add 7 to both sides. But Lord, we're not going to say that 4x plus 7 is 11x. Even though 4 plus 7 is 11, because those cannot be combined. They're not like terms. So just get in the habit of putting them on the same side, though. 4x plus 7. Jono, what would the last step be? Jasmine, last step. How? Now, unlike the last one, none of the numbers on top are divisible by 3, and even if they were, they'd have to both be divisible. So we've isolated the y, like we wanted to. Just rewrite 4x plus 7. Combine like terms. What do you see like terms? 7 and 3. So that looks like adding to you, like you're adding 7 and 3. It looks like division to me. But you can. I'll give you a decimal. Just leave it. Okay, this next one, if I had to go back, I probably wouldn't even put it here. Like the next two, actually. So I'm not going to do both of them. I'm just going to do one of them, but I can guarantee you this will not show up on a test or a quiz. Which variable are they telling me to solve for? The x, right? But what's different here? There's 2 of them. And you could be like, oh, but Mr. Romero, yesterday there was 2 variables and we combined them. Sure. But look at what's in front of these. An a and a negative 1. Those 2 are not like. They can't be combined. So the reason why I wouldn't put this on a test or a quiz is because, yeah, you can solve for it, but you have to do one of the most evil, dark, despicable things in math. Factoring. The way that these x's would come together would be to factor it out. So think of factoring as the opposite of simplifying, in this case, the opposite of distributive property. Instead of getting rid of a parenthesis, I'm going to put a parenthesis. And I'm going to get that x. Because both of these terms have an x, I'm going to get the x and bring it out. And then I'm going to ask myself, what times x gives me ax? A. What times x gives me negative x? Negative 1. So if I were to distribute, I don't want to distribute, but if I were to distribute, I will get what I started with. The reason why I don't want to distribute, well, how many x's did I start with? 2. How many x's do I have now? So now I can isolate it. How do I get rid of the a minus 1? If this means x times a minus 1, what's the opposite of multiplication? X equals c over. But again, you will not see that on a test or a quiz. You will not. No factoring. Diane, are you okay? So the next one I'm going to skip because it involves factoring also. I forgot that I had put this last sheet here with extra columns on it, so that's the only reason why I even put those other ones there. So let's just work on as many of these as we can until the bell rings. Look at number 1 on that last page. What do they want you to solve for? For A. How would I solve for A there? It takes one step. How would I get the A by itself? Get rid of the K. Good. How am I going to get rid of the K? The opposite of minus K is plus K. What is U plus K? I have no idea. So you just leave it as U plus K equals A. What? The Nedekim? United Kingdom, yes. I can see how you have so many friends. You gotta learn some new dance moves, man. You gotta learn some new dance moves. Kind of recycling all the same old ones. Alright, how about for number 2? How would I get A by itself there? Divide both sides by K. So U over K equals to A. Answer. You heard? Okay, how about the next one? How about number 3? Okay, we do want to solve for A, so how would I get the A by itself? You have to add. Definitely don't want to add. Okay, I do want to get rid of the furthest 4 away by subtracting 4. And Z minus 4 just stays as Z minus 4. That equals negative 4A. What would the last step be? Divide by negative 4. Now you're going to want to pay attention to this. Because this is actually one of the drawbacks of multiple choice. If I were to give you a quiz or a test that was free response, and you left the left side like this, Z minus 4 over negative 4, I'd be fine with it. I don't have a problem with it. But since the majority, and up to now, the entirety of what I've given you has been multiple choice, I doubt you're going to see this as an answer choice. Because most places do not like to leave a negative in a denominator. So here's the trick. You can get the number on the bottom and make it positive. But then you have to change every sign on the numerator. So what's the Z going to become? Negative Z. What's the negative 4 going to become? Positive. And again, because I don't control what's written on these multiple choice, or more like the way that they're written, another thing that these things don't like to do is leave a negative in the front. So because the Z is going to become negative, you would probably see the 4 come first, and then the minus Z. It could be, sure, I'm saying it. It shows up like that. Just so that, I don't want you to get this and say, oh man, I can't find my answer anywhere. No, it's there. They just wrote it a different way. It's worth the same thing. Here, watch. Let's see this again. Let's solve for A. If I'm going to solve for A, what am I getting rid of first? Not the 2. The C. How am I going to get rid of the C? Minus C minus C. So negative 2A is equal to, you can put 6 minus C, you can put negative C plus 6, whatever you want, just don't combine them. And then Kayla, hang in there, we're almost done. Kayla, what's the last step? Now, Kayla, last step. Divide by negative 2. Look, Hiram, for the second time in a row, I personally don't have a problem with you having a negative in a denominator, but if something's multiple choice, I doubt you're going to see it there. So they would probably put a 2 in the denominator, but then how would you have to adjust the numerator? Or you could flip it, or you could say the C becomes positive, the 6 becomes negative. Just change the signs. Albert, that's confusing to you? To get from here to here, I made the 2 on the bottom that was negative, I made it positive, right? Originally, the 6 was positive, make it negative. You don't necessarily have to write it second, but I'm just telling you that's the way that most books or tests or like test banks, whatever, I guess stuff, that's the way they're gonna write it. The C was negative, it becomes positive. Let's do another one. Here, let's solve for x. I want to get x by itself. What am I going to get rid of first? 2m minus 2m minus 2m. So negative 3x is equal to negative 6 minus 2m. What will be the last step? Divide by negative 3. Now, none of these are divisible. Well, the 6 is divisible by 3, but still, since they're both not, I'm not going to actually divide. But you'll probably see the 3 as a positive. So what are you going to see on top? Positive 6 plus 2m. You could also see 2m plus 6. It's the same thing. You feel me? No caps. Okay, how about the next one, number 6? Subtract 2. I want to get x by itself. I'm going to subtract 2. Diana is also subtracting 2. So u minus 2 is equal to negative 4x. Divide by negative 4. But you probably won't see a negative 4. You'll probably see a positive 4. So what will you probably see on the top? Or you'll probably see 2 minus 2. Hey, look, I can still do a couple more. Look at this next one. This one takes one step. How do I get the x by itself? It's going to take one step here. I want to solve for x. How do I get the x by itself?
Cancel out the m.
How?
To add
m. So plus m plus n. So this just ends up with x equals p minus n plus m. So just say that way. Yeah. How about number 8? Also one step. How do you get x by itself? Divide by c. So x is r plus b over c. I'll leave it there. I think that's it.